Welcome to tutorial 2. In this session, I will explain all the working steps for all the given questions. So for question 1, we have three equations. Okay. This is a system of linear equations. First, we need to form an augmented matrix. So in order to form this, we need to include only the coefficient matrix and the constants. The coefficient matrix is nothing but the value left at the left of the variable. So here we have 2, -1, 3, 11, 1, 2, -2, -3, -1, 3, 4, and -5. It is as simple as that. Okay. So for the next question, of course, we need to solve x1, x2, and x3 via elementary row operations. So elementary row operations consist of three major operations, which is row interchange, the addition and subtraction between two rows, the scalar multiplication of a row, or the combination of the addition or subtraction of between two rows and the together with the scalar multiplication of row. So first here, okay, we have the augmented matrix. So the technique is I want to make 2 here as the main pivot. So first I want to make this 1 and -1 into 0. So what I'm going to do is I subtract R1 together with 2 times R2 and I substitute into row 2. So we have 0, -5, 7, and 17. Okay. Next, I want to make -1 into 0. Okay. R1 plus 2 R3, substitute into R3, we have 0, 5, 11, and 1. Okay. Next, it's actually done, but we need to make this into 1 first, but I will show it later somewhere here. So just proceed here as the main pivot. Okay, what is important is here is already 0. Here I want to make this 1 first. Okay, this is the next pivot. Okay, I want to make -1 and 5 0 later. -1/5 divided by R2 divided by -5. Okay, substitute into R2. Okay, we have 0, 1, -7/5, -7/5, -17/5. And then we want to make -1 into 0, which is easy. We just need to add row 2 in row 1, substitute into row 1. We have 2, 0, 8/5, 38/5. Okay. And then next, we need to, this is the one, the missed step here. I want to make 1 here. So R1 divided by 2. Okay, substitute into R1. We have 1, 0, 4/5, 19/5. And then next, proceed to this. We want to eliminate 5, so it will become 0. So 5 R2 minus R3, substitute into R3. We have 0, 0, -18, -18. Okay. This column is done. So does this. Okay. Next. Okay. This I will choose this as the main pivot, but before that I wanna make it to become 1. So divided by -18, substitute into R3. So we get 0, 0, 1, and here 1. Okay. And then I want to make both of these to become 0. So R2 plus 7/5 R3, substitute into R2. We have 0, 1, 0, -2. Okay. And then finally 4/5, eliminate 4/5, R1 minus 4/5 R3, substitute into R1, 1, 0, 0, 3. Okay. This is a Gauss-Jordan elimination, okay, also known as that method. Okay, we reduce it into reduced row echelon form. So here is the solutions. Okay, x1 is 3, x2 is -2, x3 is 1. Okay, so for question 2, we have also a system of linear equations with three equations, three unknowns. So write it in augmented form. Here you just take the number 1 2 -1 5 3 1 -2 9 -1 4 2 0. Okay, first I want to make 1 as the main pivot, so I want to eliminate this first because it is easier. We just need to add r1 with r2, substitute to r3. So we have 0 6 1 5. Okay, 1 plus -1 0, 2 plus 4 is 6, -1 plus 2 is 1, 5 plus 0 is 5. So that's how it works. Okay. Then next, I will make 3 into 0. So 3 r1 derivative r2 minus r2 substitute into r2. So we have 0, 5, -1, 6. Okay. Okay. This column is done. Next, I will make 5 as the main pivot. Okay. Before that, I will make it into 1. Okay. r2 divided by 5. Substitute into r2, we have 0, 1, -1 over 5, 6 over 5. Okay. Next, I will get rid of this. Okay. Solve for this column. r1 minus r2, substitute into r1, observe r1, we have 0 here. So this is -1, -3 over 5, 13 over 5. Okay. This is already done. Okay. Next, solve for 6. Okay. 6 times r2 minus r3. Okay. Substitute into r3, we have 0, 0, -11 over 5. 11 over 5. Okay. This column is done, the second column. So for the third column, I want to make -11 over 5 as the main pivot. So divide by it, multiply by its reciprocal, -5 over 11, okay, times r3, substitute to r3. We have 0, 0, 1, -1. Okay. Here, we want to solve this. We want to eliminate this, so we get an identity matrix. r1 plus 3r5, 3 over 5, r3. Substitute into r1, we get 1, 0, 0, 2. Okay. This one, okay, eliminate this one. We want to modify r2, r3 plus 1 over 5, r2. Substitute into r2, we get this. Okay. And identity matrix, this is the solution. Okay. X is 2, y is 1, z is -1. Actually, this is -1. Let me change first. Okay, here it is. Okay, -1. Okay, sorry for the mistake. Okay, and I proceed to question 3. Here was also here's also 3 equations with 3 unknown. Okay. So solve for x, y, and z. So we have 3 by 3 matrix here, and then attached together with the constant. So this is in the augmented form. But this one is a little bit different because our rule in choosing pivot is we cannot have 0 pivot. Okay, that's the first rule, okay, using the algorithm. So what I'm going to do is I exchange r1 with r2. So we have 1. Okay, this one exchange with this row. Okay. We get 1, 0, -3, 1, and 0, 8, 16, 0. Okay, just change the order of the row. Next, okay, this one is non-zero pivot, so it is safe. Okay. Already, moreover, it is 1, so I don't need to modify it anymore. So here, we don't have to modify it anymore also because it is already 0. -4, however, it's not 0. We want to eliminate -4 so that it will become 0. Okay. 4, r1 plus r3, substitute to r3. We get 0, 14, -10, and 10. Okay. Column 1 is done, and then move to the second column. We choose 8. Okay. 8 is a non-zero, so it's fine. But before that, I want to divide it by 8, so it will become 1 here. Okay, divided by 8. Okay, the entire row 2, we have 0, 1, 2, and 0. Okay. And then this one 0, we don't have to bother row 1. We don't have to modify r1, so we are going to deal with 14. Okay, r3. So 14 r2 minus r3, substitute into r3. Okay, we have 0, 0, 38, -10. Okay. Column 2 is already done. Then column 3. Okay. This is our next pivot, the final pivot. Okay. Here, okay, as usual, divided by 38 because we want to make this as 1. So for our row 3, we have 0, 0, 1, negative 5 over 19. Okay. And then next, I want to make this. I want to eliminate both negative 3 and 2 from row 1 and row 2 respectively. So first, I'm going to solve for R1, R1 plus R2, 3R3. Substitute R1, we have 1, 0, 0, 4 over 19. Okay. Next, finally, we're going to eliminate this to become 0. So R2 minus 2R3, substitute into R2, we have 0, 1, 0, 10 over 19. So this is already in reduced row echelon form. And this is the solution for x, y, and z respectively. So x is 4 over 19, y is 10 over 19, okay, z is negative 5 over 19. Okay. Notice that all of the given questions have unique solutions. Okay. Both of them have specific value of x, y, and z. In some cases, okay, in a linear system, okay, we have three cases: a unique solution, infinite solution, and no solution. Okay. Infinite and unique solution are considered as consistent. No solution is considered as inconsistent. Okay. For infinite and no solution, they have their own ways to solve the question. So in this tutorial, uh, this session is done. So thank you for listening.